How to sketch graph of a polynomial function. This is what we learn now in this video. So we have a function here which is minus 3 times x plus 3 times x plus 1 square times x minus 2 cube. Now to sketch any polynomial function, most important things which you want to know are these listed right here. So first is degree, then the leading coefficient, and behavior, x and y intercepts, and you need to understand nature of zeros. Important thing is x-intercepts and zeros are very different. X-intercepts are just the points where the graph crosses x-axis, while zeros tell you how they cross x-axis, which is dependent on the order of zero, right? For example, x minus 2 has an x-intercept at x equals to 2, but it crosses like a cubic function. And x plus 1 has x-intercept at minus 1, it crosses, rather bounces back like a parabola, right? That is how, and this is a linear zero. So we're trying to understand this also while we sketch. Accuracy of the graph is basically based on nature of zeros, correct? So what we'll do is we'll just draw xy axis here, and this is a very rough sketch. I'm not doing any graph. I'm trying to teach you how to really sketch a graph, right? Then when you have a proper graph paper, you can have actual points and draw a neat graph. Now let's go through these questions and understand the concept. So degree. So when you have a factored form of a polynomial, degrees just multiply and add them up. So when you multiply factors, degrees get added. That's the law of exponents, right? So it is 3 plus 2, 5 plus 1, 6. So the degree is 6. So 6 is our degree of this particular function, and it is also named as, polynomials are named based on degrees. You can actually call it a sextic polynomial, right? Of polynomial of degree 6. It means even degree, and it means end behavior, both are on the same sides. Now which side, up or down, depends on the leading coefficient, and we can see here that the leading coefficient is negative. So an, the leading coefficient, is negative for us. That means that both sides are actually facing downwards, right? So it's not up. So this is kind of end behavior for you, right? So it is like kind of like this. So that is the end behavior of our function. So we can write here end behavior, which is if x approaches positive or negative infinity, y approaches negative infinity, correct? So that is, we get kind of end behavior. You can see how roughly I'm sketching it. It really helps find x and y intercepts. Now you can see from here x intercepts, we have 3 of them here, right? So starting from the very first one, it is at minus 3. So x intercept is at minus 3. Let's say this is my point minus 3. That is my first x intercept. Second one minus 1. Let's say this is my minus 1. And the third one is at 2. Let's say this is 2. These are my x-intercepts. Now y-intercept. Y-intercept is plug in 0 for x, and then what do you get? So you get, let me calculate now this. That means we are trying to find what is f of 0 equals to. So f of 0 is minus 3 times 3 times 1 times minus 2 cube, which is minus 8. This is a very important exercise now for you to do. It is a checkpoint for you on the graph, okay? So it is minus and minus becomes plus, right? Now 8 times 9 is 72. So it is 8 times 9 is 72. That is what you get, a very big number, right? So I'm not going to scale this at all. But wherever my graph crosses the y-axis, I'll write 72, and that's the way it should be done, right? Okay. Understand nature of zeros. Most important to sketch your graph. And that's why I didn't do anything on this graph after putting the x-intercepts. This particular video is probably the most extensive on this sketching graphs. And always read this first and then move on to the other videos, because I'm not really explaining all these points in the other videos. So you can go through it once again to understand what we're trying to say here, okay? Now, let's get back to nature of zeros. We have already plotted the zeros here, but we didn't really mention how will they behave. Nature of zeros is decided by the degree or order of the zero. Now this one, which is the first zero for us, it is a linear zero. Linear because its degree is just 1. So it acts like a line. So the graph will cross here like a straight line like this. Do you see that? Now we already know the end behavior, and that is why I'm crossing it from this side. Okay, so from negative infinity we are approaching, crossing the x-axis. The second one is of order 2. Order 2 is like a parabola. So this zero will not cross the line. It will be bouncing back on the x-axis like I've shown here. It's very important for us to show this, right? And then the third one is of cubic order. So cubic curve is like a tilde here. So it is like going like this straight and then going like this. So that is the kind of shape which you get. I need you to practice this shape because this will help you to draw a smooth graph. And that's the end of it. So we could have actually gone here and shown the end behavior like this. See how you get your graph. And of course when I connect these points, I will get my y-intercept somewhere on the top, right? So I have a y-intercept, and it's all the exercise of connecting them, right? So I'll get connecting them. So you see that part? So this is my part. Now y-intercept, as I said, is a test point for me, plus 72. I will write 72 here. So I'm sure I am on the right side of the graph. Do you see? And now I can go back here and say, we can say, well, this is like going like this down, and here I can connect these points again and get my graph. So that is my polynomial function f of x. Do you understand? So this is maybe a rough sketch, but it's good enough. When we say sketch a graph, this is fairly good enough sketch, right? So this is our x-axis, and that is y f of x. So that is how you get your graph, right? So understanding nature of zeros is kind of very important. So whenever you write x-intercepts next time, mention order of zeros. So here -1 was order 1. I mean -3, the first zero, was of order 1. The next one was of order 2. So it bounced back. And the third one was cubic in nature, order 3. So specifically I took this example with 3 different kinds of zeros. So if we have a linear zero, it will cross the line like, cross x-axis like a line. If it is even zero, it could be 4 also. It will bounce back. But if it was 4, it will be flatter. Cubic zero is like a tilde shown here, right? If it is degree higher, for example 5 and 7, we'll make it flatter. That is how we actually sketch the graph of a polynomial when the function is given in factored form. I hope you understand and appreciate it. Share it with your friends and move on to sketch more graphs. Thank you and all the best.